Hi there, my name is Scott Munter, and I'm an applications engineer with Command Automation, a high-tech distributor of automation and motion control solutions. The tutorial I'm going to show you today is how to connect a third-party device to an Omron PLC over Ethernet IP using Sysmac Studio. Let's take a look at our demonstration setup so that we can see where we will get to by the end of this demonstration. The controller that we have here is an Omron NX102 automation controller. It is connected via Ethernet IP to a Turck TBEN-S2-4IOL compact IO link block. There are a few devices attached to this IO link block. The first is this Omron Photo Eye IO link sensor, series E3Z. Over here we have a Banner TL50 light stack. This stack is connected only by digital outputs to view the invocation status of our controller. And it won't be used for the purposes of this demonstration, but over here is an analog interface module from Phoenix Contact. It converts an IO link port into an analog output signal. For example, this one is 4 to 20 milliamps for use with other control systems. So what we're going to show today is how to set up the communications between the Omron controller and a Turck block. Then, to show that they are working, we'll write a small program to toggle an output on the light stack when the photo eye sensor is triggered, as you can see here. Let's begin. First thing we're going to do is open up the Turck service tool. This will allow us to find our Turck device and parameterize it. Search for the devices. I only have this device on our network. Let's assign an IP address to that so that both our PC and our Omron PLC can connect to it. I'm choosing 192.168.0.251 for my block. Then let's open the web browser and view the status. There are a few diagnostics on this because I haven't set up the parameters. There's a few things that I need to set here just to make sure that we're on the right page. We can log in to change these parameters using the default password of password. First thing, activate these outputs. This will let me activate the DXP output. Some IO blocks set this by default, not this one though. Next thing, because I'm not using port 1 and port 4 as IO link, I'm going to use them as simple digital input devices. This will prevent it from sending a fault if I don't have them connected as IO link devices. Now if I check my diagnostics, I have no issues on the block. The next thing we need to do is download our EDS file so that we can import that into Omron's Sysmac Studio to communicate with the Turck block. I can do that selecting a link here and going on to Turck's website. Under configuration file, select the EDS file, and we'll save that to our desktop. Once I have that downloaded, I'm going to open up that file, find those EDS sheets, sort this by type, and here are all my Turck IO block EDS sheets. Now I need to load these into our Omron tool. The location that Omron expects to see these tools is under this PC, C, Windows, Program Files, x86, Omron, Sysmac Studio, IO Device Profiles, EIP Connection, and EDS. All we have to do is drag and drop all of our EDS and EDH files into this folder. Since I've already done this before, we're just going to skip those through. Now, we can start up Omron Sysmac Studio and begin setting up the device in there. Let's create a new project. We'll call it Turck. IO test. set the controller that we're using. Don't worry, if your controller is different, you can change this later. And we'll create our project. Now, let's set up our Ethernet settings so that we are communicating on the same subnet as our Turck block. Go to Configurations and Setup, Controller Setup, Built-in Ethernet IP settings, and we'll edit that. I'm going to communicate with this device. I'm going to assign an IP address of 192.168.0.250. Now the next thing we need to do is actually create the variables to hold the data from our Ethernet connection. So we're going to go to our global variables data. We're going to add a new tag or two. First one is going to be Turck TBEN-S2-4IOL IO. We'll just create, for now, a basic word array with 104 elements. How do you know how big that needs to be? Let me show you. If I go back to our Turck page, I can look at our Ethernet IP memory map. This shows me that in my input assembly has an instance ID of 103 and a size in words of 104 words. My output assembly is an assembly ID of 104 and 66 words. Great. Now, what I'll do is I'll set my input to publish on the network as an input, and my output to publish on the network as an output. I don't have to do this here, but it will make our life easier in the future. Next thing we want to do is set up our connection. Go to Tools, and we'll go to Ethernet IP connection settings. Great, now we have our Ethernet IP connection settings. Right click on port 1, because that's the port that we're connected to. Select Edit. The easiest way to do this is when we're in our tag set database, we're going to just register those two tags that we set. So we'll just say register all tag sets. That finds those two devices that we published as an input and an output, and we'll register tag sets according to them for an input tag and an output tag. Now I can see my input 208 bytes or 104 words, my output 132 bytes. Now we need to add the connection to the actual device. We'll switch down here to connection device, and we need to add a target device in our toolbox over here. We're going to add one now. We'll set up our node address. This is the IP address of our Turck block, 192.168.0.251. We'll select our model name in our dropdown. If you don't see it in this list, this is because you didn't properly import the device in the folder EDS file in the folder. That's where this pulls from. We can add this now. Now it knows that we have this device with this IP address. Drag and drop that into our connection settings, and that'll load it in. We have to set up our target variables and our originator variables. The target, those are 104 and 101 and 103 assemblies. Like we said, 101 is our input, and 104 is our output. Let me just confirm that. You can see 103 should be our input, and 104 should be our output. So we want to change that. And then our originator variables. This is the variable that we set up on the PLC itself that will receive these variables. Turck EIP in and Turck EIP out. And I'm just going to change this RPI down to 10 milliseconds. Depending on your network setup, you may be able to do more or less. Great. That's all we need to do to set up the Ethernet IP settings. Let's go online with our controller. Because it's a new project, we'll have to tell it that this is the controller that we want to connect to, and synchronize this to our PLC. Make sure that if we're transferring this Ethernet IP settings, that you uncheck the box that says do not transfer the Ethernet IP connection settings. Okay. Now we should be online and connected to our device. To confirm that our connection is set up, we can go back to our Ethernet device list and select monitor. This shows us that it's blue, which means that we are successfully connected to that node. We can view each of our tags and view that those are connected. Let's go and look at the actual variables and make sure that we're seeing the input data come from the device. I'm going to pull up a watch table to view these individual words in my assembly. Select our Turck Ethernet IP in. Great. And now I can see here, note this is my 108 words. This word right here, if I change it to decimal, this is the analog value on my IO link sensor. If I put something in front of that sensor, we should see that change, like so. So that means that we're reading data. Great. Now, this works. We can communicate, but there's another step we can take. What if instead of looking at these devices in an arbitrary field of values, we set up a structure to be able to represent that data in a more user-friendly manner? Well, that's great. I've already done that for you. Let me show you how we add a library to be able to talk to that data. I'm going to go to our project in my library, look for show references. I'm going to add this library. This is a library that I can make file. Again, if you want to get this file, please reach out to your command automation representative that's closest to you. Open up that Turck Ethernet IP test library. And now we'll see that in the data for the library, we have these data types which include TBEN inputs, TBEN outputs, status words, basic inputs, basic outputs, the link data, the input diagnostics, and the channel diagnostics. So now let's update our global variables to use that data instead of using these clunky word arrays. All I gotta do is Turck TBEN inputs, Turck TBEN outputs. Now let's resynchronize this. And we should be running again. Let's look at that data again and see what it looks like now. If I go into a watch table, now I can look at Turck Ethernet IP in and Turck Ethernet IP out. Now if I inspect this data, I can see my basic data with all my channels, my digital inputs, whether the input is valid or not, and the actual input value of the DXP input. I can see, for example, in my port 3, which is my Ethernet IP sensor, this was the word that we were looking at earlier. This is my data word, word 1. Value is 1024, 1280. Again, if I put something in front of the sensor, you'll see that number change. If I want to set an output in this device, I can do that directly in the watch window. All I have to do is go to my Turck Ethernet IP output block, find my basic data. We'll change that channel 7 digital output from false to true. Now you can see here in my input assembly that that channel 7 DXP input value is reporting as true, and the light on my light stack is lit up. So the one last thing to do here, let's make a little program so that we can confirm that we can address these variables inside our program without having to make changes. I'm working with my new program, section 0. Well, they have one rung here, so we'll just input a contact. We'll set that to be our Turck ERP in dot basic data dot channel 5 DXB input value. That's the trigger value on our E3Z photo eye. I'm going to set an output here, and we'll go Turck EIP out dot basic data dot channel 7 output. Let's synchronize this one more time. And now we can view the functionality as established in our demonstration. If I trigger this input value, our output will light up, and the physical output on the light stack will light up as well. I hope you learned something from this demonstration. If you have any questions, please contact your nearest command automation representative. My name is Scott Munter. Have a nice day.